So this video is going to look at coordinate geometry of the line. I'm going to break it into two different videos and that should cover the full topic. Deals with a lot of substitution, which is again going back to our very first chapter of algebra. So you're subbing in your coordinates into your different formulas. Yeah, and that's it. So I'm going to start first of all with the first part is looking at our XY axis. Okay, so this XY axis that we're very used to seeing in functions and graphs and other strands of maths, this is known as our coordinate plane or our Cartesian plane. Okay, now each of our coordinates, so I've listed A, B, C, D, and E here. Each of our coordinates is an X and a Y. Okay, so the number on the left hand side is always your X and the number on the right is your Y. So you could be asked, first of all, to plot these points onto your coordinate plane, or you could be given a point on the coordinate plane and asked to name what the point is. Okay, so let's just go through these first of all. So I'm going to just quickly number this. So 1, 2, 3, 1, 2, 3, -1, -2, -3, -1, -2, -3. And obviously I should be using a ruler and we should be making sure we've equal spaces between each of the numbers. So first of all, A is 1, 3. So 1 is the X. So we go to 1 on the X axis. Okay, and we go up to 3 on the y-axis, so our point A will be up here. Point B, -2, -1, so -2 is on the x-axis, -1 on the y-axis, so B is going to be here. C is 2 -3, so 2 is the x-axis and -3 is the y-axis, so that's C. D is -2, 2, so -2 on the x-axis, +2 on the y-axis, so D is here. And E is 0, 3, so 0 on the x-axis up to 3 on the y-axis, so E is actually on the y-axis. Okay, so just be careful with those ones. So let's look at F. They're going to say to you to label F, which I'm going to say is 2, 0. And G, I'm going to say is -1, -2. So they're now, sorry, I've done that backwards. What I'll do is I'll just put F here, okay, and I'll put G here. Okay, so I want to do the reverse of that activity. So they're going to ask you now, what are the coordinates F and G? So you're given the points on the diagram and you need to label them. So F is going to be, it's 3 on the X and 1 on the Y. So it's 3, 1. And G is going to be -1 is the X and -2 is the Y. Okay, so just make sure you're confident with that. You might be asked to either plot these points onto the diagram or they might plot them onto the diagram for you and you need to be able to label them. Okay, second thing that comes up is the distance between 2 points. This could also be asked as the length of the line. So the same formula for the distance between 2 points or for the length of a line. So our formula is the square root of x2 minus x1 to be squared plus y2 minus y1 to be squared. Okay, so you're going to be given your points. Okay, so they'll say find the distance between these 2 points or find the length of the line that contains these 2 points. Each of your points, okay, is going to be x1, y1, x2, y2. And I get into a habit of doing that every time at the start of a question. So for example here, we've 1, 5 and 2, 3. and they're going to say find the distance between these 2 points. I start by labeling x1, y1, x2, y2. And all I'm doing then is subbing in to your distance formula. So our distance formula is the square root of x2 minus x1. So x2 is 2, minus x1 is 1, and in the formula all of that is to be squared, plus y2 is 3, minus y1 is 5, and all of that is to be squared. Now you can be doing a lot of this stuff on the calculator then, once you've subbed it in. So 2 minus 1 is 1 squared. 3 minus 5 is minus 2 to be squared. 1 squared is 1. Minus 2 squared, be careful here, minus by a minus is plus, and 2 by 2 is 4. So the distance between those 2 points is the square root of 5. And remember, you can be using your calculator and putting all of that in if you wanted. And they might ask you to give your answer correct to a certain amount of decimal places. So for example, 2 decimal places, so 2.236. 2 decimal places, we look at the third digit. And because the 6 is 5 or greater, it's going to round that 3 up to a 4. So 2.24. Okay. Mostly they're not going to give you units here. They're not going to say millimeters, centimeters, anything like that. So you should be fine. But remember, that's a distance. So it's 2.24 units. It's not squared because you're not finding an area there. It's just the length of something. Okay. So we're going to look at another couple of examples. And the reason I'm doing that is because of the signs here. Okay. So next example, I'm going to label my points x1, y1, x2, y2, and I'm subbing in to my formula x2 minus x1 to be squared plus y2 minus y1 to be squared. So we have the square root of x2 is 2 minus x1 is minus 1 to be squared. So notice we have a minus and a minus coming together here. With a minus and a minus, they're being multiplied, and minus by minus becomes plus. So that sign in there is now positive. y2 is 6 minus y1 is 4 to be squared. So 2 plus 1 is 3 squared, plus 6 minus 4 is 2 squared. 3 squared is 3 times 3, which is 9. 2 squared is 2 times 2, which is 4. So your answer is the square root of 13. You could leave it at that, or if they ask you to give your answer to decimal places, you would go back, put it into your calculator and do that. So I'm just trying to do these 2 examples to show you just some examples of where you might run into some sign mistakes. Okay. Next example, I'm going to go ahead again and label x1, y1, and x2, y2. So subbing into our formula, x2 minus x1 to be squared plus y2 minus y1 to be squared. Just to say about the formulas there, all of those are in the log tables. Okay, so all formula will be given to you. So just opening up the log tables, having it open in front of you, and just keeping an eye on the formulas. Be careful not to make some silly mistakes at this point. So square root of x2, so we've 3 minus x1 is 5 to be squared, plus y2 is minus 4, minus y1 is minus 2 to be squared. So again, just looking here, we have a minus by a minus, which becomes plus. So we just need to be careful of that. 3 minus 5 is minus 2 squared, plus minus 4 plus 2 is minus 2 squared. Minus 2 by minus 2 is plus 4, plus minus 2 by minus 2 again is plus 4. So we have the square root of 8. I'm just going to write there. You can be using your calculator for most of that. Like I didn't use the calculator for any of this. you could just be putting all of that into the calculator, getting the square root of 8, and again checking that in the calculator. Okay, so quite nice so far. Just notice it's called the distance formula, but it finds the distance between 2 points, and it also finds the length of a line segment. So just be careful of the wording of the question. So next we're looking at the midpoint of a line segment. Okay, so midpoint obviously means the point that is halfway between two other points. Okay, this formula is for when you're given 2 points. Okay, if you were given 2 points on a diagram, it might be straightforward to just see on the diagram what the midpoint is, but most of the time you will use your formula. So formula for midpoint is x1 plus x2 over 2, y1 plus y2 over 2. And notice I have a comma in between because your answer is a coordinate. You're looking for a point. So it's an x and a y. So you're going to be given your 2 points. First thing I always do is label x1, y1, x2, y2. Subbing into our formula, we've x1, which is minus 1, plus x2, which is 5, all over 2. y1 is 3, plus y2 is 7, all over 2. Okay. Minus 1 plus 5 is 4, over 2. 3 plus 7 is 10 over 2. So your midpoint is 4 divided by 2 is 2. 10 divided by 2 is 5. So that would be the point that is halfway between those. Let's just quickly look at the sketch. Okay. If we've minus 1, 3, that's going to be up here. Minus 1 and 3. 5 and 7, so 5 would be, say, here. Again, mine's not going to be accurate. 7 would be up here somewhere. Okay. So if we have our 2 points, that means this would be the line. And it means that we're looking for, the halfway point, which would be here somewhere. And it does look like it would be around 2, 5. Okay, so just think about, like, when you're doing that, does my answer make sense in relation to the question? So let's move on to slopes. Now this is a long section. There's a lot to this. This is probably one of the most important parts of coordinate geometry of the line, and you really need to understand all the different ways we can find the slope in order to be able to go on and work with the equation of the line, parallel lines, perpendicular lines. So this is probably the most important part of this section. So we're going to break this up into different sections. First thing we're going to look at is the slope of the line when we're given the picture of a line on a diagram. Okay, now what we're going to do if we're given the picture is we're going to find the slope by finding the rise over the run. Okay, now that means we're going to find the rise is the vertical difference between the 2 points, and the run is the horizontal difference between 2 points. Generally, our slope is a fraction, okay, and the slope we usually refer to as m, and you'll see that later on when we go to the equation of the line as well. Okay, so I'm going to look at 2 different examples, and we're going to look at the rise over the run to find our slope. So there's 2 points marked on this line. You don't necessarily have those points in the question. There might be no points marked on the line, so it will be up to you to mark the 2 points in. Any 2 points. You can pick any 2 points on the line. So the vertical difference would be this line here. And you can see the vertical difference between these 2 points is 2. Okay? The horizontal difference between these 2 points goes from here to here. And we can see the horizontal difference is 3. So the slope of this line, okay, is the vertical difference, which was 2, over the horizontal difference, which was 3. Okay? Now, I'm going to talk about the direction of the line, okay? And remember, we're always talking about from left to right. So if I look at this line and I move from left to right, that line is going uphill from left to right. And if our line is going uphill from left to right, it's always a positive. So I'm leaving this 2 over 3 as positive 2 over 3. Okay? In my second example, and if I move from left to right, my line is going downhill from left to right. So a negative slope is always going to move downhill from left to right. So it's up to you to remember at the end of doing the rise over the run, you need to make sure that a negative slope has a negative sign. So let's look at the rise over the run here. So the rise between the 2 points, again, is here, and the run is here. So you should notice it ends up making a right angle triangle. So the rise, I'm going to call this M because our slope is M. Our rise goes from the x-axis up to 2, so the rise is 2 units. And the run goes from -1 to 3, which is 4. It's up to us to remember it's a -2 over 4 because it's a negative sloping line. And we're going to simplify that as 2 over 4 minus a half. Okay, so this here at the bottom, the note is very, very important. So if it's going uphill from left to right, it's always going to have a positive sign, which we don't actually write down, but it's going to be positive. And if it's going downhill from left to right, it's going to be a negative slope. So you always have to make sure there's a negative sign in the front. Okay. Next, we're going to look at the slope when we're given 2 points. So if you're given 2 points and it says these 2 points form a line, what is the slope of that line? So your formula is y2 minus y1 over x2 minus x1, which actually mimics the same idea as the vertical difference over the horizontal difference or the rise over the run. Now, if we look at the 2 points we're given, again, x1, y1, x2, y2. So we're going to sub into the formula. So y2 is 2. Minus y1 is minus 1 because there's a minus in the formula and there's a minus with the y1. Over x2 is 5 minus x1 is 3. So first thing, minus by a minus, that becomes plus. So we've 2 plus 1 is 3. 5 minus 3 is 2. So the slope of that line is 3 over 2. Okay. Looking at parallel lines and slopes. Now, they obviously don't look a bit parallel. Didn't use a ruler and I should have. But parallel lines, we always talk about like train tracks, okay? So two lines that will never meet. So naturally enough, if these two lines are two lines that run along the same track but never meet, they always have the same slope. Okay, so as soon as you see the keyword, the two lines are parallel in a question, in your head you're thinking, okay, they have the exact same slope, and you will need to know that. You'll need to use that quite a bit in these questions. Okay, perpendicular lines. Okay, perpendicular lines are going to be T-shape and form a 90-degree angle. Okay, so 90-degree angle here if these are perpendicular. Now, perpendicular lines, okay, we can see there will be a negative line and a positive line. So these actually have opposite slopes. And what this means is when you multiply one of the line slopes by the other line's slope, you should always get -1. So for example, the slope of this line is +3/4. The slope of this line is -4/3. Multiplying these fractions, because we're multiplying the two slopes, so we've 3 times -4 plus by minus is -12. 4 times 3 is +12. -12 divided by +12 is -1. So that's always how you check if lines are perpendicular. We'll see more of this later on, but it's important to know that. So they always have opposite slopes. When you multiply them, you should get -1. So this is what opposite slopes would look like. And when I multiply them, I get -1. So that's how I know that yes, they're perpendicular. Just to notice here, if I was told that one slope was 3/4, what is the slope of a line that's perpendicular? Notice what's happened. We flipped the fraction upside down and the positive has become a negative. Okay. So let's look at an example. It says A, B, C, and D. So there are 4 coordinates. Show that the line AB is perpendicular to CD. Okay, so this is a typical exam question. The line AB, so we're now going to have to find the slope of the line AB and the slope of the line CD, and we have to hope that when we multiply their slopes, we get an answer of -1 to show that yes, they are perpendicular. So the first thing I'm going to do is labeling x1, y1, x2, y2, x1, y1, x2, y2. And we're going to use our slope formula, y2 minus y1 over x2 minus x1. So y2 is 2, minus y1 is 0, over x2 is 3, minus x1 is -1. Minus by minus here becomes plus. So 2 minus 0 is 2. 3 plus 1 is 4, which is the same as a half. On the other side, we have our points labelled and subbing into our formula y2 minus y1 over x2 minus x1. So y2 is -2, minus y1 is -4, over x2 is 2, minus x1 is -1. So just here we've our minus and minus becomes plus. So here we have -2 minus 4 is -6. 2 plus 1 is 3. And if I simplify that, we've minus 6 over 3 is the same as minus 2. So dividing the top and the bottom by 3, minus 2 over 1. And if you notice our two slopes here, we have a half, and if we flip that, we've 2 over 1. This is positive and this is negative. Now if it says show, what you really should do is multiply a half by minus 2 over 1. 1 times minus 2 is minus 2. 2 times 1 is 2. Minus 2 divided by plus 2 is minus 1. Therefore, we just do AB is perpendicular to CD. Or instead of writing the word perpendicular, you can just do this symbol here that shows they're perpendicular. Okay? So very typical exam question. So yeah, let's keep moving on. The last part of the slope is if you're given the equation of a line. So we're going to look at this in the second video, but I just wanted to show that if you were given the equation of the line, something like 3x plus 4y minus 5 equals 0, and they said to find the slope. Okay, if we have the equation of the line written in the form ax plus by plus c equals 0, then your slope is equal to minus a over b. Okay, so a is going to be the coefficient, the number in front of x, and b is going to be the coefficient or the number in front of y. So if I was to write down the slope of this line here, it will be minus a, so minus 3, over b, which is plus 4. So that's my slope. Okay, let's look at another one. Minus 2x plus 5 equals 4. So written in the form ax plus by plus c equals 0, it doesn't make a huge difference here because this 4, sorry, that should be y. When this 4 comes over, it's going to be minus 4 equals 0, but it doesn't impact the slope. So minus a over b, so minus a is minus 2. So minus 2 over b here is plus 5. We just need to change this to minus by a minus is plus. So our slope would be 2 over 5. Okay, so I'm going to stop that first video there and we'll move on to the equation of the line in the next video. You will need to use everything from the first video, will most likely be needed in video 2 as well, particularly the stuff that we did on slopes. So make sure you're confident with the slopes before we move on to the second video.